Hi everyone, welcome to Javatechie. This is part 2 video of our Kafka series. In this tutorial, we are going to discuss about Kafka architecture and its components. Okay, alright. If you understand the Kafka terminology and its purpose, then you can picturize internally how a message is going to flow from producer to the consumer via broker or Kafka server. Okay, so without any further delay, let's get started. So these are the Kafka components, or you can say core concept of Kafka. Here each component play a different role in the Kafka ecosystem. No worries, we'll discuss one by one. Okay, so let's begin with the first one, that is producer. If you understand the PubSub model in our previous video, the producer is the source of data who will publish the messages or events. The consumer acts as a receiver. It is responsible for receiving or consuming a messages, but they won't directly communicate with each other. To process the messages from producer to the consumer, there should be one middleman between them. That is what called Kafka server or broker. In PubSub model, usually producer will publish or push the messages to the broker, then broker will store that messages, and then consumer will consume it from the broker. In other words, you can say a broker is just an intermediate entity that helps in message exchange between a producer and a consumer. Okay, so this is what the basic key component of your PubSub model and producer, consumer and broker. Let's move to the next one, that is cluster. So I believe everyone heard the word called cluster. If not, a cluster is a common terminology in the distributed computing system. It is nothing but just a group of computers or servers that are working for a common purpose. Since Kafka is also a distributed system, it can have a multiple Kafka server or brokers inside a single Kafka cluster. So there can be one or more Kafka brokers inside a single Kafka cluster. Let's assume your producer is publishing huge volume of data. Then a single Kafka broker may not able to handle the load, right? So you might need to add additional Kafka server or additional broker. So you can group multiple broker using a Kafka cluster. Fine. So next, let's deep dive inside the brokers to understand what all core components it has to store the messages. Okay. So let's move to the next component, that is topic. So before I explain the theory, what is the topic, let's find out why it is there inside a broker. Let me walk you through the same PayATM example. As you understand, the PayATM application will keep sending different type of activity to the Kafka server, and the PayATM client app will continuously listen the messages from the Kafka server, right? So here the left part is my producer and the right side is my consumer, and the middleman is the broker, or you can say Kafka server. So broker receives different type of messages or events here. It can be a payment transaction, or it can be a ticket booking, or it can be a specific to the mobile recharge related message, right? Now consumer needs to read all the messages to process them. So the consumer asks to the broker, hey, give me all the messages you have received. Then the broker checks his storage and replies to the consumer, hey consumer, I have a lot of messages with me. Which one you need? Again consumer asks, hey broker, give me all payment specific messages. Again broker attack with the counter question, hey buddy, I have different type of payment messages with me. Which one you need? Now it's gone, right? The consumer hurts by broker counter question. This is obvious, right? Then how we can overcome this back and forth conversation? That is where topic came into picture to categorize different type of messages. So how topic can help here? You can simply create multiple topic to store different type of messages. Even you can rename the topic payment topic, booking topic and insurance topic. If producer sending payment specific messages, then the message will push to this particular payment topic. If the message type or producer is sending booking related messages, you can keep those messages inside this booking topic. Or similarly, if producer is sending some mobile recharge specific information, you can keep it separate topic. This is how you can segregate different event type to different topic. So here consumers have no need to have a back and forth communication with brokers. Whatever messages consumer want, he will simply needs to subscribe that specific topic. For example, I have a consumer who needs only the booking specific messages. Then I'll tell him, hey consumer, you go and check directly in the booking topic. You no need to ask to the broker to give me booking specific messages. You simply go to the booking topic or you simply subscribe to the booking topic and get all the messages what you need. This is very simple, right? Alternatively, you can consider the topic act as a database table in Kafka ecosystem. So usually we store employee information in the employee table and payment information in the payment table in database world, right? Similarly, when producers send employee specific event or messages, we need to store them in the employee topic. And similarly, if producer is publishing payment specific information, then we need to store it into the payment topic, right? Now, if you have multiple consumer, then they can go to a specific topic and consume the messages as per their need. For example, if consumer 1 wants to read all employee messages, he can go and collect the messages from the employee topic directly. He no need to ask to the broker, hey broker, give me the employee specific messages. He know that employee topic contains all the employee specific messages. Consumer 1 can come to the employee topic and can get the info. Similarly, all the consumers can subscribe to the corresponding topic what information they want to listen. Okay, so if you look into its actual definition, topic specifies the category of the messages or the classification of the messages. Listeners can then just respond to the message that belongs to the topic they are listening on. So consumer 1 want the payment info, he can go and listen to the payment topic. That is what the need of topic or this topic play a critical role in Kafka ecosystem. Okay, so let's move to the next key component, that is partition. Now we know that Paytm producer sends data to the broker and the broker store the message inside a topic. Now consider you have a huge volume of data. When I say huge volume of data, let's assume your producer is publishing millions or billions of messages per second to the topic. Then will my topic be able to handle those many messages? Obviously no. There could be a storage challenges, or it can be very challenging for the topic to store data on a single machine, right? Then how to handle this situation? Solution is very simple. As we already know, Kafka is a distributed system. In such a scenario, we can break the Kafka topic into multiple parts and distribute those parts into different machines. This concept is called topic partitioning, and each part is called partition in Kafka terminology. Okay, so this partitioning will give you better performance and high availability, because if you observe, we split our topic to multiple partitions. So when producer publish bulk messages, then each partition concurrently accept the messages. That will definitely improve the performance, right? Even in case if any partition goes off, then other partitions are available to handle the loads without any application downtime. This is the reason topic partitioning is the key aspect in the Kafka ecosystem, and we can decide the number of partitions for a topic during Kafka topic creation. Okay, no worries, we'll hands on with these terms in our coming videos. So now let's move to the next component, that is offset. So far we understand a Kafka cluster can have one or more Kafka server. Then a Kafka server can have multiple topics and each topic can have multiple partitions, right? Now when producer send a message, then it will go and sit in any partition inside a topic that we don't have any control on it. It will work based on the round robin principle. So if you observe, as soon as message arrives in a partition, a number is assigned to that message, that is called offset. 0, 1, 2, 3, 4, 5. These are the sequence number assigned to each and every messages, that is called offset. So the purpose of offset is to keep a track of which messages have already been consumed by the consumer. For example, let's consider after reading 4 messages from the partition, consumer went down. Okay, then when consumer will back to the online, then this offset value would help him to know exactly from where the consumer has to start consuming the messages. Now here if you observe, consumers should start reading message from offset 4, not from the 0 again, right? This is what the key role of offset. Fine. Now let's move to the next component, that is consumer group. So I believe we all are clear up to this. Producer will push huge volume of messages to the Kafka topic, and message will again split to different partitions, and inside partition each message have their own identity with offset number. So now let's go one step ahead. Who will listen to the messages from the partitions? The single statement is consumer, right? But if you observe here, I have 3 partitions and a single consumer is reading from each and every partition, which will definitely leads the performance issue because there is no concurrency. You can see here a single consumer is playing with all the 3 partitions. So definitely it won't give us the better throughput, right? Then how we can overcome this situation? It's very simple. Just share the workload. How can I share the workload? So what I will do, simply I will define n number of consumer instance. Now I can group all the 3 consumer what I define into a single unit by specifying the group name, that is called consumer group. Now payment consumer group have the 3 consumer instance. Now since I have multiple consumer with me, I can divide the workload to each and every consumer to achieve better throughput. So simply now my consumer 1 can read from partition 0, consumer 2 can read all the messages from partition 1, and consumer 3 can read from the partition 2. Then in this approach, all the 3 consumer instance read parallelly from each and every partition, which will definitely give me the better performance, or we can get the better response, right? Just keep a note, we can't guarantee about consumer and partition order. Any consumer can talk to any partition, that will be decided by the coordinator. Okay, so you can say consumer 1 might listen from partition 2 or any order. Okay, we don't have any control on it. Cool. Now you might have a question, hey, I have 3 partition, so 3 consumer, so they will talk to each other. That's correct. But what if I have a 4th consumer added to my consumer group? Then what will be the behavior of this consumer 4? What he will do? Right? There is no change. That consumer 4 will sit idle because there is no work for him now. Since all the 3 partitions assigned to 3 different consumer instance, there is no partition left for him. So he will simply sit idle. But in case if any consumer instance is rejected or goes off, then C4 will get a chance to connect with any partition. This concept is called consumer rebalancing. Don't worry, I will cover this part in the coming session. Okay, fine. Now let's move to the next component, that is Zookeeper. So Zookeeper is a key component for Kafka. Kafka is a distributed system and it uses Zookeeper for coordination and to track the status of your Kafka cluster. Okay, it also keeps the track of Kafka topics, partitions, offset, and all the component of the Kafka ecosystem. So in single word you can say this particular Zookeeper will act as a manager for your broker or for your Kafka cluster. Okay, so this is what all the key component of Kafka. We have seen the concept of Kafka architecture. Moreover, we discussed Kafka components and basic concept. So furthermore, for any query regarding architecture of Kafka, please feel free to ask in the comment section. We'll discuss more internal of each components in our coming session. Okay, that's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.